Good day, good people. Let us look at hydraulics, the second part. The second part of hydraulics, we are dealing with hydraulic pumps. The first one we were dealing with the hand pump, of which this is what we were dealing with on the first part of hydraulics. Now the second part of hydraulics, we are dealing with the pumps. Now, hydraulic pumps are used to transmit liquid vertically, horizontally, or against pressure. The volume of the liquid transmitted has weight due to gravity, and the liquid must be transmitted over a certain distance or height. When a force is moved over a distance, work is done. Please make note of that. All these types of pumps are used to deliver liquid at a pressure. We are having different types of pumps that we can use to deliver liquid at the pressure. We are having the centrifugal pump, we are having the piston pump. We would look into potential energy as well. Why potential energy? Because of what it's been said here, right? The volume of the liquid transmitted has weight due to gravity, and the liquid must be transmitted over a certain distance or height. Meaning you can have your pumps, and obviously you would use the hydraulic hoses. Those hydraulic hoses, some of them they will be horizontal, some of them they will be standing vertical. All right. Now, the first part of hydraulic, we looked at the hand pump, and we did indicate that it is driven by human ability, whereby you put your effort on the handle, then you do the pumping. Right, that's what we said. Okay, now on the second part, your pump, your pump, it is now driven. The weight itself, pump, it is now driven mechanically. Your pistols are now driven mechanically, okay, with the pump motor. When the pump motor, it is connected, you are having something like this. When it is connected, you are having something like this. You are having, this is your pump motor connected to your crankshaft. Then as your pump motor rotates, your crankshaft rotates, then your cylinders, they go in and out, in and out, in and out. Like we are having here, you can tell this is the crankshaft, then connected to the pump motor, rotating at a certain speed. As it's rotating at a certain speed, then your crankshaft will be going to and fro. Your cylinders will be going in and out, in and out, in and out, right? That's what we will be dealing with here. Now, before we can continue, let's make one thing to be clear. If you were to be asked, what is the difference between the plunger pump, hand pump, plunger pump, and the plunger pump and the piston pump? Their difference, it is on their stroke length. This is where the difference is, on their stroke length. The stroke length of a hand plunger, it is longer. Plunger, it is longer than the stroke of what of your pistols. The stroke length of the pistols, it is shorter. The difference between the hand plunger pump and the piston pump is on their stroke length. The stroke length of the hand plunger is longer than the piston pump stroke length, meaning this one, it is short. This one, it is longer. Right, that's where the difference is. If you were to be asked, what's the difference between the two? Now, as we said, that pressure does not depend on the size or shape of, it depends on the content, and the pressure on the plunger side equals to pressure on the ram side. That's what we said, isn't it? Now, we then went ahead and calculated pressure. We said pressure equals to force over area, looking at the area of this cylinder and the area of that cylinder. Then we went ahead and we calculated the volume. the volume on the plunger and the volume on the ram. We said volume per stroke length, it is area of the cylinder multiplied by stroke length, and we got our volume. Then we as well considered the number of strokes. We said if we are given the number of strokes, it will be area, stroke length, number of strokes. The number of strokes, it is denoted as N multiplied by number of stroke. The SI unit, it is M cube, because the N, no SI unit. Right. Now, that which we did here on the hand plunger, we as well looked into how to calculate the slip. We said the slip, it is VP minus VA. Then we said the slip percentage. Slip percentage, we said it is VP minus actual volume divided by VP multiplied by 100. Then we got our slip percentage. Right. Now, that which we did on the hand plunger, it is exactly the same as on the hydraulic pumps, looking at the piston. Now, it's like you are dividing this application into two. This side now becomes the piston side. It is driven by a pump motor. It is no longer driven by human ability. It's like we are dealing with the plunger side, because the ram side, it will be like we are dealing with, the ram side is like we are dealing with accumulators, right? But we will deal with that as we proceed. And of each the ram side, it is the accumulators anyway, pending how you look at this and the application of it. Now, when coming to the piston part of it, when we calculate the volume, they would say to you, calculate the volume as per stroke length. If they are saying calculate the volume as the per stroke length, then it will be VP equals to area multiplied by stroke length, then you get your M cube. Now, if they are saying calculate the volume on the piston as per the cylinder, meaning they then want you to consider the number of cylinders connected on your crankshaft. In this example of mine, I'm having 3 cylinders connected on the crankshaft. And the number of cylinders, it is denoted as what? As C. C indicates the number of cylinders. The number of cylinders. Okay. Now, in calculating the volume, as per the cylinders, it will be VP equals to area stroke length multiplied by C. C, no SI unit. It means the SI unit would be M cube. Now, if they then want you to calculate the volume, as per the crankshaft, meaning now you consider the rotational frequency, the speed at which the pump motor is rotating. Now, the speed, it is denoted as N for rotational frequency. Now, in calculating the volume as per the crankshaft, volume as per crankshaft, shaft, it will be VP equals to area stroke length multiplied by N. The N, it is the rotational frequency. Then the SI unit for N, it is either rev per second or rev per minute. Now the SI unit of volume here, it will be M cube per second. Why? Because it will assume the per time of what? Of your rotational frequency. Here they are. Pump delivery. Volume of liquid delivered per stroke by a single cylinder. This is the formula. That's what we've touched on. The volume of liquid delivered by a single cylinder. This would be the formula. A volume of liquid delivered per crankshaft. This is the formula. Now we have what we call theoretical volume of liquid delivered by a pump, and it is denoted as QT. Now the QT includes all the elements on these formulas. It is area, stroke length, rotational frequency multiplied by number of cylinders. The SI unit, it is m cube per second. Now this is the formula of theoretical volume. It is QT equals to A multiplied by L multiplied by N multiplied by C. Then the SI unit, it is m cube per second. Now, you then need to know how to calculate, or rather how to convert 1 m cube into liters. Because they will either ask you to calculate the volume, but they would want it in liters. Now you then need to know how to convert. Now in converting m cube to liters, you will multiply by what? By 1,000. Then in converting liters into m cube, you will divide by 1,000. Right. You will divide by 1,000. Now please make note, if you are given the information or the data, and you are given the volume in the form of liters, you then have to convert those liters into cubic, because our formulas are designed in such a way that they accommodate. They are designed in such a way that they accommodate m cube. Okay, I'm not saying we don't have formulas of working the liter with liters and whatsoever, but on our level, we will be dealing with m cube. They are designed to calculate the m cube. Then you can convert the final answer into liters. Please make note. Now, as much as we said that where the pumping will take place, as the cylinder goes in and out, there would be a loss of fluid. And that loss of fluid, it could be as a result of the broken seal or something. Then we said the loss of fluid, it is called the slip. Then we said in calculating the slip, it is like I've indicated earlier, in calculating the slip, we said this is the formula of calculating the slip, and the slip percentage, this is the formula. But the fact that we will be looking at the now we will be using in calculating if the flow rate it is given, okay, meaning the QT it is given, you can calculate your slip using this formula. Slip equals to QT minus the actual volume. This is the actual volume, actual rate flow. This one, it is the rate flow. Now it will be QT minus QA. Then the slip percentage would be QT minus QA divided by QT multiplied by 100. Then you get what your slip. You can tell that there's nothing that has changed much. The only thing it is now, the pump, it is mechanically driven, no longer human driven. That's where the difference is. Okay, but everything that we've worked on the first part, looking at the hand plunger, it is exactly the same as when connected to the crankshaft. The difference is that now the hand plunger stroke length, it is longer comparing to the piston. Now for you to have the great volume, you then have to either install more cylinders, so that they can pump more hydraulic or more fuel or more water for you. Okay, that's what we'll be basically dealing with or calculating. Then we are having the hydraulic system of hoses. Now connected to the crankshaft and all that, the cylinder will be going in and out, in and out, in and out. Yeah? Now as it's going in and out, you can tell that the fuel or the hydraulic will be drawn from the tank. Then the valve will open at a certain pressure, whether it's a one-way valve. Then we are having different types of valves as well. It will open at that pressure. When it opens, the liquid will be stored in here. Then the cylinder will come in. Then this valve will close. As it comes in, this one will be opened at a certain pressure. As it gets to be opened, then the oil or fuel will be delivered in various components on your machine. Now the whole system here, it is called the static head. Remember when we were introducing hydraulic, we said the volume of liquid transmitted has weight due to gravity, and the liquid must be transmitted over a certain distance or height. And when a force is moved over a distance, work is done. Now, under this system, the work, it is done when the force shifts and at a certain height, everything it is delivered, the work it is done. Now, we will then be able to use the static head to calculate the work done. Now, the static head, it is big H equals to small hd for delivery plus small hs for suction, okay? Then you get what? The static head. Now you will use your static head to calculate the work done. It is force multiplied by hs, or we can calculate power would be work done divided by time. And remember, since while we are dealing with the hydraulic hoses, in calculating the work done would be pressure multiplied by volume. Now, if our volume it is per time, then we can then calculate power. It is pressure multiplied by volume per time. Then we get what? We get power, okay? Then calculating right. Now, these are the formulas that we'll be working with to calculate whatever that they want us to calculate. Now, we will be using these formulas. Now, in calculating pressure on your hydraulic hoses, it is pressure equals to density multiplied by gravity multiplied by height. And the height there, it can be the static head, right? Now, we will be using all these formulas to calculate whatever that they want us to calculate, more especially when we are looking at the hydraulic hoses, you know, the whole system including the hydraulic hoses. Now, why gravity? Gravity because it has an impact on hydraulic hoses standing vertically, because the liquid has to be transmitted at a certain height. Now, anything acting against gravity, we know that gravity has an impact because it's pulling it down. Now, it will affect the rate at which the liquid flows. Now, this is the formula that we'll be as well working with to calculate whatever that they want us to calculate. Now, the second part of hydraulic, that's exactly what we'll be dealing with here. We are dealing with cylinders connected to a crankshaft to a motor. As the motor turns, then the cylinders are going to and fro, drawing hydraulic oil and delivering hydraulic oil in various components and all that, like in this picture here. That's exactly what we are dealing with. Is it different from what we did on the first part? No, it's not. It's not. The only thing that has changed is that now we are having the rotational frequency, and we are now having the flow rate, of which it is QT, theoretical volume, and it includes all this component in calculating the required what? Volume. Okay. Now, this is what we will be dealing with. Please make note of every formula that we touched on. Now, they can want you to calculate the number of turns. Another formula that you can use, or the rotational frequency, I mean to say, it will be QT equals to volume multiplied by N. You can calculate your volume from area, stroke length, number of cylinders. Then you make N the subject of the formula, because we know that volume, it makes up what? Volume. Then you can then make N the subject of the formula, QT over QT. It will be QT over V. Then you get what? Your number of turns. This would be the volume displayed per stroke, per stroke or per cylinder. It will either be per stroke or per cylinder. It will depend with the given data. What are you given? Now, Another formula that you need to take into consideration, it is the efficiency part of it. We know that no pump is 100% efficient due to energy loss during the operation. Now, you might be given the efficiency and they would want you to calculate the theoretical volume. In calculating the theoretical volume, it will be the efficiency multiplied by V, okay? And this is nothing new. We've already worked these formulas. Multiply by N, rotational frequency. Or the N, it is included. Or it will be efficiency multiplied by V per second. It means when it is like this, the N there, it is included. How you want to see it, it doesn't matter, but please make note of this information here. Now, this is what we will be using to calculate whatever that they want us to calculate, okay? We will be using these formulas to calculate anything that they want us to calculate. Now, let's look at the application of the second part of hydraulics. I will post it now. All right. Or let's look at it. Let's look at it. We can do it now. Okay. Let's say we are given. Okay. The work done during the working stroke of one cylinder pump is 4.2 kilojoules. The effective force on the piston is 20 kilonewton and the piston diameter is 245 mil. Now, they want us to calculate the pressure during the working stroke. Now, let's take out the data. Sorry that I didn't write the equation down. But let me repeat the given statement. The work done during the working stroke of one cylinder, we know that our C equals to 1. One cylinder pump is, now the work done, we are given the work done. The work done, it is 4.2 kilojoules, okay? The effective force on the piston, then we are given the force on the piston, it is 20 kilojoules, yeah? Then we are given the diameter of the piston, it is 245 millimil. Then this would be 0.245 meters, okay? Now, question number 1, they want us to calculate the water pressure during the working stroke. They want us to calculate the water pressure during the working stroke. We know that in calculating pressure, it is pressure equals to force over area. Do we have force? Yes, we do have force. There it is. Do we have the area? We can calculate the area. Area, it is pi multiplied by small d squared divided by 4. Then it will be pi multiplied by 0.245 squared divided by 4. Then our answer, right? Oh, I don't have a calculator with me. Then we get our area. Then let's summarize, say pressure equals to force. Force, it is 20 times 10 to the power 3 divided by pi multiplied by 0.245 divided by 4. Then we get our answer. Okay, let's punch it. Get a calculator and punch it. Okay. Then I get my answer as 424,236 kilopascal. That's what we get as our answer. Since well they said calculate the water pressure during the working stroke. Then question number 2, they want us to calculate the stroke length of the pump. Now, in calculating the stroke length of the pump, we are given the work done. Then we are having force multiplied by stroke length, the distance. Okay, we have the force, we have the work done. Now, stroke length would be work done divided by force. Then our energy, it is 4,2 times 10 to the power 3 divide by 20 times 10 to the power 3. This 10 and that 10 will cancel out. Then we are having 2,4 divided by 20. Then we will be able to get our stroke length. Then our stroke length would be 0.21 meters, and that would be 210 millimeters. Okay. Then the third question, they want us to calculate the volume of water delivered per working stroke. Okay. They want us to calculate the volume delivered per working stroke. Now, in calculating the volume of water delivered per working stroke, I will post this question after I've posted the video. You will find the question below. I will post the question or the link below where you can get this question. Right, and the solution worked out for you properly so. Right, the volume of water delivered per working stroke, okay? Now in calculating that, it will be work done equals to pressure multiplied by volume. What is it that we are looking for? For volume. Now, volume would be work done divided by pressure. Now, it's one of the formulas. I don't know if I did indicate that formula of calculating. Yeah, there it is. There it is, the formula. I did indicate it. There it is, the formula that you have to use. It is work done equals to pressure multiplied by what? By volume. That's the formula that I've used in calculating that. Do I have the work done? 4,2 times 10 to the power 3 divide by, we did calculate our pressure, and there it is 424,236 kilopascal. Then it will be 424,2 is it 424,236, okay, times 10 to the power 3. The K and the K will cancel out, and we will be left with 0.0099 m cube. Then they want our answer per working stroke. Then that's what we get. Now, we will then have to convert our answer into liters. We'll then have to multiply by 1,000. Then in multiplying by 1,000, it will be 1, 2, 3. It will be 9,9 liters. That's how you tackle this question. Now, the last question that I have in applying for what we just spoke about on the second part of hydraulics, they want us to calculate the mass of water delivered per working stroke. Now, the mass of water, we know that it is density equals to mass over volume. They want us to calculate the mass. Now, then the SI unit, it is kg per cubic. They want us to calculate the mass. And calculating the mass, it will be mass equals to density multiplied by volume. Do we have density? Yes, it is 1,000. Multiplied by the volume. Do we have the volume? Yes, we have. There it is. We've calculated the volume. There it is. It will be multiplied by 0.0099. You don't use the liters. Like I said, that our formulas are designed to accommodate the m cube. Then our answer here would be 9,9 kg. Right. This is how you tackle these questions. This is how easy it is. I will then post more application on the second part of hydraulics. Thank you, good people.